Every single piece of technology we use, the phone you're holding, the car you drive, the satellites flying way up over our heads, it all starts as rock in the ground. But the way we get those critical metals is going through this quiet revolution. So today, let's dive into the new science of how we're literally forging our future.
And this brings us right to a huge paradox, a real catch-22 at the heart of our green ambitions. How are we supposed to build a world of clean energy when the materials we need come from an industry that's historically been anything but clean?
And this is really the core of the problem. On one side, the demand for metals to build electric vehicles, wind turbines, you name it, it's just exploding. But on the other side, the traditional ways of getting those metals use massive amounts of energy and create a lot of emissions. It's a puzzle we absolutely have to solve.
So, how do we solve it? Well, the answer, it turns out, lies in reinventing one of our oldest industries from the ground up, making the whole process of extraction smarter and a heck of a lot cleaner.
Okay, first up is a technique with a fancy name, hydrometallurgy. But the idea is pretty simple. Instead of using tons of heat, think fire and smelting, this process uses liquids. Basically, a special chemical bath to pull metals like copper, nickel, and cobalt right out of the rock. It's a total game changer, especially for cutting down on air pollution.
So how does it actually work? Well, it's basically a three-step dance. First, you've got leaching, where the ore gets dissolved into a liquid. Then, extraction, which is all about isolating the specific metal you're after. And finally, precipitation, which sounds complicated, but it's just pulling the pure metal out of that liquid. The concept's pretty straightforward, but the impact is, revolutionary.
But what if we could make this whole water-based process even more natural, more efficient? What if we could start, get this, using life itself to mine our metals?
This is where it gets really cool. We're talking about bioleaching. Essentially, we're using tiny microorganisms, little microscopic miners, to do the heavy lifting for us. These tiny powerhouses literally eat away at the ore and release the metals. And the benefits are huge. It's cheaper, uses way less energy, creates fewer greenhouse gases, and it's perfect for tapping into low-grade ores we used to just throw away as waste.
But, innovation isn't always about inventing something brand new. Sometimes it's about taking the classic methods, like pyrometallurgy and electrolysis, and giving them a serious 21st century upgrade.
Just take smelting or pyrometallurgy. The old-school way was dirty with high emissions and not always great results. But modern smelting, it uses these highly controlled atmospheres to slash those emissions and get way more metal out of the ore. And it's the same story for electrolysis, the process we use for aluminum, which is now being redesigned to run on renewable energy. Okay, so we're getting smarter about pulling stuff from the ground, but what if the most valuable mines aren't actually deep in the earth? What if the richest resources are hiding all around us, maybe even in your junk drawer at home?
This really begs a critical question. With the massive need for things like cobalt, lithium, and all those rare earth elements that make our tech work, where are we going to get all of it?
The answer, believe it or not, is hiding in plain sight. It's our electronic waste. Yep, all those millions of old phones, dead laptops, and used-up batteries, they're becoming one of the richest and most important new mines on the entire planet.
And the benefits of this urban mining are just enormous. For one, we don't have to rely as much on digging new holes in the ground. It also helps build a real circular economy where we reuse what we already have. And crucially, we get to reclaim all these valuable materials that would otherwise just sit in a landfill forever. It's just a smarter way to do things.
Now, it's really easy to get excited about all these breakthroughs, and we should be. But let's be realistic for a second. Progress isn't always a straight line, and these new technologies face some pretty serious hurdles.
The first big one is energy. Even the modernized versions of electrolysis and pyrometallurgy are still incredibly power-hungry. They just need a ton of electricity to work. So, to make them truly green, we have to power them with green energy. It's that simple.
Next up, there's the problem of what gets left behind. Even the so-called cleaner methods like hydrometallurgy can produce some nasty chemical waste, and managing that waste safely is absolutely critical. We have to make sure we're not just swapping one environmental problem for another.
And finally, there's the whole world of geopolitics. The hard truth is that a lot of key materials, especially those rare earths, are concentrated in just a small handful of countries. That creates these really fragile supply chains, where one political shift can throw everything into chaos. So let's just quickly recap those challenges.
The high-heat methods have a massive energy problem, the chemical methods have a potential waste problem, and our need for rare earths creates a huge supply chain problem. It seems like every path forward has its own unique obstacle we have to figure out.
So where does all this leave us? Well, we're right in the middle of forging a new future for metals. And it's all about finding that delicate balance between our growing demand for stuff and our responsibility to the planet.
And let's be clear, this isn't some pie-in-the-sky idea for 50 years from now. It is a real shift towards sustainable, efficient, and environmentally conscious practices that is happening as we speak. This transformation is already underway. Which really brings us to the final, most important thought. The question for us is no longer if we can get the metals we need in a cleaner way. We know we can. The technology is there. The real question is, what choices are we going to make to ensure we do it responsibly?